Hello and welcome to our discovery and recommendations for the global retail analysis of your business. My name is Daniel Groves and my group members are Bruce Hedrick, John Mackay and Mary Ward. We will be reviewing the data on promotional markdowns and total sales across your 4-store locations in Munich, Dubai, London and New York. We are passionate about helping you better understand your customers and going above and beyond for improving their overall experience with you. In our presentation today, we will start by looking at some issues we hope that we can get answers for you. Some further background on the data we'll also provide, as well as some highlights from our analysis and initial hypotheses. And finally, we will make some recommendations based on our findings. We want today to root our presentation in the words of Charles Whelan. It's easy to lie with statistics, but it's hard to tell the truth without them. We are here today to make the hard calls and let you know what the sales data you've provided us really tells us about the promotional markdowns in your business. The main issue we want to see answered is, can we find strong correlation between market conditions and total sales from promotional markdowns? The second issue we want to review is, when are promotional markdowns the most successful in increasing total sales? If we understand this, then we can better understand and serve customers more effectively. On this slide, we see that the data that has been collected each week from each of your stores, we've broken the data down into departments, as well as looking at temperature, fuel price, CPI, unemployment, these variables, and then also looking at, on a nominal scale, is something a holiday or not a holiday? These variables, all of these, we've gone and categorized into nominal or scale variable types. These are the null and corresponding alternative hypotheses that we will further analyse throughout our data inspection today. We're going to look at sales across all stores and seeing if they're equal or different. We're going to look at consumer price index and sales, as well as then expand that out and see if CPI is a better independent variable or predictor of total sales than temperature, as well as unemployment. We're going to look at holidays and how that impacts sales. And finally, we're interested if women clothing sales significantly increase based on temperature. So let's look at total sales. Using simple data analysis, we can quickly conclude that we can reject the null hypothesis here, that all sales are the same across all stores, because we can see that Dubai and New York have higher sales than London and Munich. The next question we want to look at is CPI and total sales. Is there a relationship between these? In this evaluation, the dependent variable is total sales. The independent variable or predictor is CPI. The null hypothesis is that there's no linear relationship between the two. The alternative hypothesis means there is a linear relationship between the two. On the correlation table on the right, consumer price index is negatively correlated with total sales, and that's at negative 0.191. In the model summary, in the table on the bottom left, CPI is the independent predictor entered and has an R-square of 0.037 or 3.7%. And this is significant at an alpha level of less than 0.05. The regression model that we're looking at takes the form of y equals B0 plus B1 CPI. So this says that total sales is equal to 39,411.105, take 94.557 CPI. To go with this, the t-test statistic of negative 2.796 is significant at p equals 0.006 levels. The standard coefficient beta is the amount of change in the total sales for every standard deviation change in CPI. For every standard deviation change in CPI, there's a negative 0.191 standard deviation change in total sales. In the bottom right-hand corner, we see the normal PP plot, and that's evaluating the linear relationship of CPI and total sales. From there, we can conclude that there is a reasonable linear relationship between CPI and total sales for the year, albeit some values have deviated from the diagonal. In conclusion, we choose to reject the null hypothesis, and we believe there is a correlation between consumer price index and total sales for the year. Next, we want to look at CPI and how that can be whether that's a better predictor than temperature and unemployment on total sales. So our null hypothesis is that it's not a better predictor, and our alternative is it is the best predictor of total sales when compared against temperature and unemployment. We see that each independent variable is negatively correlated with total sales. That means each unit of temperature, unemployment, or CPI increase we see a decrease in total sales. 3 models have then been run, and this is in the bottom left-hand corner. The first had temperature as the only independent. At an R-square of 0.087, that means that the temperature accounts for 8.7% of the variance in total sales. And at p equals 0.001, this is a significant amount. The second model added unemployment as an independent variable. The 2 independent variables, R-squares of 0.095, indicates that the pair account for 9.5% of the variance in total sales. Once again, this amount is significant. The R-square change indicates that we've got the ability to explain another 0.8% of the variance in total sales by adding unemployment to the model that only had temperature in it. The third model and the final model added CPI as an independent predictor. The 3 independent predictors R-squared is 0.123, and this indicates that the trio accounts for 12.3% of the total variance in sales. Once again, this is a significant amount. The R-squared changes indicates the ability to gain an extra 2.8% of the variance in total sales by adding CPI to the model that already had temperature and unemployment in it. Now note that this 2.8% is a lot less than the 8.7% we can predict from temperature. Our regression model is in the form of B0 plus B1x plus B2x plus B3x, and its total sales is equal to 55,040.78, take 370.726 temperature, plus 6385.106 unemployment, take 242.428 CPI. It's surprising that unemployment has a positive effect on sales once CPI is added to the model. This suggests a potential linear relationship between the two, and we need to continue to explore it. In the third model, the t-statistic tells us that the temperature is a significant predictor, while holding constant for the effects of unemployment and CPI. Additionally, CPI is also a significant predictor while holding constant for the other 2 predictors. However, unemployment is not a significant predictor while holding constant for the effect of CPI. The part column indicates the unique contribution of an independent variable to account for the variance in the dependent measure. If you square this value, you can interpret it as a percentage of variance uniquely accounted for by this independent variable. Temperature is accounting for 6% of the variance over and above the other variables in this model. You would lose that percentage of the variance accounted for if you remove it from the model. Unemployment is accounting for 1.5 of the variance over and above the other predictors in the model. CPI is 2.8%. You would lose that percentage if you removed it from the model. The VIF column can help indicate multicollinearity in our model, suggesting that the independent variables are duly related to each other. The VIF of 1.052 for the temperature suggests it's not related or correlated at all with unemployment and CPI. However, the VIF of 8.487 and 8.638 suggests there is moderate to strong relationship between CPI and unemployment. This needs to be further explored and suggests a weakness in the model. In this analysis, finally, we can conclude that we reject the null hypothesis and therefore conclude that CPI is not the best predictor of total sales when put against temperature and unemployment. Temperature is the best predictor. After running an independent t-test, we can see that the variances between holidays and non-holidays are not equal. This is shown by the significance of the Levine's test for the equality of variance. Therefore, we cannot assume equal variances. We then need to have a look at total sales and when equal variances are not assumed. We can see the significance of 0.003 at that significance level for two-tail. So when that becomes one-tail, it decreases to 0.0015. We can clearly see that is significance at a 0.05 level. Therefore, we can reject the null hypothesis. As we have a look, we see that in general, number one means that it is when it's a holiday, and the mean is a lot greater at 46,000 than when it is a normal day and it's not a holiday at 18,000. We can therefore conclude that the average total sales for the year on holidays will be higher and significantly higher than on non-holidays. The last analysis we wanted to run was to look at temperature and whether that increases, whether when the temperature increases, sales in the women's department increases. Surprisingly, in this one, we had to accept the null hypothesis and reject the alternative hypothesis because we could not conclude that a level of significance existed between temperature and markdown sales in the clothing department. Surprising for me, it's actually got a negative correlation that as temperature goes up, sales in the women's department goes down. But we can see at 0.061 significance, one tail, it is not significant what happens here. There is not a correlation. As we accept the null hypothesis, we can see below on this graph that it clearly demonstrates that the relationship between temperature and markdown sales in the women's clothing department is not linear. There is not a strong relationship there that's of a linear nature. So our recommendations. Our first and major recommendation is that price markdowns should be used during holidays. These are successful and sales increase on these days. Our second recommendation is each store is in a different country and therefore national holidays are celebrated at different times throughout the years. Stores need to be aware of the upcoming holidays and make sure markdowns are available and promoted strongly during the holiday season. And finally, since it's the company's overall goal to continue wowing their customers with top-line products and experiences, we suggest continuous curiosity. Although we did not find a relationship between any of our variables, we think it's important to continue to build your brand and delivering more to your customers. By collecting more data through surveys and finding out client preferences for products, promotions, and locations, you can deliver a better customer experience and increase your bottom line. Thank you very much.